So we're next going to start taking a look at another case study that will illustrate some interesting aspects of using various Java concurrency mechanisms and parallelism frameworks in the context of Spring WebMVC. And this particular example is going to show how you can use functional programming and various Java frameworks in a case study that uses Spring WebMVC to check the primality of large integers. So we're kind of doing some cool stuff, which will again go back to doing prime number computations just because they burn a lot of CPU. And you can see here that we're going to have a client-server architecture where we're going to have a program called PrimeCheck test, which is going to generate HTTP requests and get responses back using Spring WebMVC. And it's going to send them over to this PrimeCheck server application, which is going to have a controller and a service which will further delegate down to strategies. And we'll talk about why we do things this way. And all the code is in the EX1 project in my WebMVC folder in the Live Lessons GitHub repository. So we're going to show off how to do all this computation using both sequential clients and parallel clients and sequential services, service implementations, and parallel service implementations. So it's going to show all different combinations of sequential and parallel. As you'll see, the client can be instructed to send requests either one at a time. Like let's say we have 1,000 numbers and we want to find out if they're prime or not. It can either send them out one at a time, or it can send them in bulk. It can say, here, server, you go figure out all these things in bulk. And you can also do those things either concurrently or sequentially. So we'll see how the client can be programmed quite easily to do all those things without really breaking much of a sweat. The server can receive the request sent to it either individually, if that's the way the client sends it, or in bulk, if that's the way the client sends it. And the server has different implementation strategies that can process the requests it receives either sequentially or in parallel using various Java frameworks. And you might not be surprised to imagine that we're going to do sort of a bake-off to see how things perform in terms of different models, sequential versus concurrent, and so on. There's a controller, because this is Spring, that automatically takes the HTTP GET requests, and it converts the GET requests that come across basically as URLs into Java native types, like an array of integers. And then it's going to forward them to the service, the PC server service, to do the processing. And the PC server service will take the request it's given, and then it will forward it to the appropriate strategy implementation. And I'll show you how to do that, and I'll explain why we do it this way in this context. The given strategy that's forwarded from the PC server service will then do the work to check the primality of the integers passed to it from the controller and the service using the appropriate Java concurrency and parallelism framework. So an obvious question to ask at this point is, why do we have these extra levels of indirection here? Why don't we just have a bunch of microservices that are often running and the client just sends directly to them? And the answer is very simple. For this particular example, I didn't want to start having to get into the more sophisticated concepts of having multiple microservices and then having clients either talk to the individual microservices directly, which is one way to do things, or a better way to do things, which we will also cover, is how to have there be something called an API gateway. And in the API gateway model, the client will talk to just one microservice or one API gateway, and then it's the API gateway's responsibility to route the request transparently back to multiple microservices running in the background. That's the right way to do it, ultimately. This approach is an incremental way of being able to test out a bunch of different approaches, a bunch of different strategies for concurrency, without having to explain the concepts of API gateways and how to launch all the different things. And it's also easy to test this with Spring, because the Spring testing framework makes it easy to start up a single microservice automatically for testing purposes, rather than having you have to start them yourself and write a separate client. And therefore, we could run all this stuff with a simple push of a button, and everything was taken care of under the hood by Spring. So this is not necessarily the way you would do a production system, but it'll get the key points across about concurrency, which is really the point we're covering here now. So what's the structure of this project? So we've got a client package and a server-side package. So the server-side package has a server folder, which contains the app entry point, which is PC server application, and PC server controller, and PC server service. Probably could have just called them PC controller and PC service, a little verbose, but I wanted to be consistent with client and server here to make it clear. And then there's also a set of strategies, and we're going to have the abstract strategy, which is the root of the other strategies. We have one that uses completable futures, one that uses parallel streams, and one that uses Java structured concurrency. So those are the three different strategies we use here. There's also some common classes, one called components, which keeps track of some of the beans we need, constants, which are used for both client and server to keep track of things like the names we're going to use for the get mappings, and then some options. And these common capabilities are meant to be specific to this application, but they could be shared between client and server, so that's what makes them common. Then we also have another set of classes I put in the utils directory. My personal style, which you're welcome to do something different in your own work, is to put stuff that's intended to be generically reusable across projects into utils. So I have this futures collector, future utils, prime utils, runtimer. These are all classes you'll see used in other examples as we go through the class. And then finally, there's another folder called resources, which defines various application properties like the server name and the port number that it listens on, waiting to be connected to by clients. Speaking of clients, the client folder has a test driver, which is going to measure the time needed to send and receive these requests and responses to and from the microservice running on the server and display the results. So that way we can do a bake-off to see which approach, how each approach performs. And then there's a client folder, which basically has the client code. You can see we have a client for completable futures, for parallel streams, and structured concurrency. And they all share the same proxy. We'll see how that works in a second. And then we have a utils folder, which contains something called random utils, which generates random numbers, and web utils, which you've seen in the programming assignment that does stuff like make calls that will return lists of things and so on as little helper classes. And we've also got some other stuff that I should have pointed out. We also have some other cool things that are handled over here in components, which is basically a pooling mechanism for connection pooling. And you'll see why we need connection pooling when we use Java structured concurrency. And you'll learn more about that. That's going to be another great quiz question. The reason we use connection pooling with structured concurrency is because if we don't, we'll have 1,000 threads, all of which are trying to make simultaneous connections to the server. And even though we can easily have 1,000 threads, we can't easily have 1,000 connections. So we're going to use a connection pool to minimize the number of connections we're going to have open at any point in time. So that'll be a fun discussion when we get to that part of the walkthrough. So that's a quick overview of what this case study is about.